couple of warm-ups to get started. All right, Emery, start us off.
X minus 8 and x plus 8.
Yep, x minus 8, x plus 8. Kinley, how about 9y squared minus 25?
3y minus 5 and 3y plus 5.
Good, so that one was a little different because that first term had a 9 on it, but 9's a perfect square, so it still follows the same pattern. Max, you get the weird one with the green triangle thrown in, but how do I factor that?
Triangle minus 7, triangle plus 7.
Yep, triangle minus 7, triangle plus 7. Because they're all perfect squares, and so they all follow that pattern. So it doesn't, as long as it's a perfect square, you apply the pattern and you don't worry about what the green triangle, what's going on there. No big deal. Today we're going to learn a different pattern, and so we'll have to know the pattern and then apply it to things that aren't perfect squares, but perfect cubes. Sum and difference of cubes. I guess maybe the first thing we should say is those warm-ups were all difference of squares. Difference of squares. Do you remember how to factor a sum of squares? That's kind of a trick question. How do I factor x squared plus 4? It's a trick question. Well, if you do x plus 2, x minus 2, you end up with x squared minus 4. You can't do it, is the short answer. That's not factorable. And there are a few on today's worksheet that are not factorable. So make sure you know that, so when you're getting frustrated and you're like, I can't figure this one out, well, maybe it's because it won't factor. So with squares, it has to be a difference. It's got to be minus, 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 minus. But with cubes, it can be a sum or a difference. So there's a big difference already between dealing with squares and cubes. Okay, so let's say we want to factor x cubed minus a cubed. X cubed minus a cubed. Let's don't go left to right. Let's do it like we did the others. Let's go down. So this is just going to be a pattern you're going to have to memorize. Like after you do it a bunch of times, it'll be as easy as any of the other math patterns that you know. The first piece is pretty easy because you just take the cube root of both of those pieces. So x and a.
Do we have like 3 parentheses?
You don't have 3 parentheses, but a lot of people are going to put that as their wrong answer. X minus a. And then the second parentheses is a little bit longer because there's going to be 3 terms in there.
X2 and minus a2. And you add them together.
Okay, so you're not far off. The first term is going to be square the first. Square the first. And we are going to have an a squared, but it's going to be back here at the end. And it may feel like I'm going out of order, but when I do these problems, this is how I do it. I square the first and I square the last. And then in the middle is you just multiply the 2 together. X times a, or alphabetically ax. So the first set's pretty easy, just cube root both of them, x and a. Second set, square the first, square the last, multiply the 2 together in the middle. Now there's still some missing stuff in there. Like, what am I missing in there? The signs, like what the signs are. Okay, there's an acronym for the signs. Students will start calling these SOAP problems. S for same. You want to guess what, if S stands for same, you want to guess what O stands for? Opposite. So if we started with a negative, this next one will be positive because it's always the opposite sign. And you want to guess what AP might stand for?
Negative? No.
It's two words. The first one starts with A, the second one starts with P. And it has to do with signs. Tells you which sign it is. How about P? What sign starts with P? Always positive. So that's the new thing for today. You've got to learn that pattern. Let's do it with plus, but it works the same way.
Mr. Wolf, you're my favorite AP.
Always positive.
All the our APs suck.
So what do you think goes in the first parentheses if it's x cubed plus a cubed? X. What sign should I use? Plus. In fact, some people will set up the same opposite always positive first. Same opposite always positive. What goes in the first blank of the second parentheses? X squared. Square that first term. And what goes in the last blank? A squared. Square the second term. And what goes in the middle? AX. Multiply the two together. So I suppose you could say that's two new formulas, but I would say that's one new formula. Like, everything's the same. The only thing that's different is the signs, but SOAP helps you with the signs. Okay, let's do one that doesn't just have X's and A's in there. Let's do one with y cubed minus 27. Okay, so I guess the first question is, do we recognize that those are both perfect cubes?
No.
Did we cube something to get to y cubed?
Oh wait, the egg of that could be cubed.
What would we cube to get to y cubed?
Why?
Careful. To get to y cubed? You answered the next question. It would be y. And what would we cube to get to 27? 3. And what sign should I use on my first parentheses? Y minus. Because it's the same. And then I'm going to go ahead and set up my second parentheses, primarily so that I don't end up using 3 parentheses, as some people like to do who, I don't know what they're thinking. Same, opposite, always positive.
Wait.
That sets up. So SOAP is great, and you'll remember SOAP, but it tells you the signs. It doesn't tell you what goes everywhere else.
Well, y squared.
Y squared, because we square the first term. I'm going to jump to the end because I think that makes more sense in my brain. What goes in this last spot? 3 squared, and what's 3 squared? 9. And what goes in the middle?
Negative 3y.
3y. Don't worry about the signs because the SOAP thing took care of the signs. So you don't have to worry about that being negative. So just do 3y. And that's your answer. I would say be careful on the factor completely problems. People will try to factor the second part more because it looks like a normal type factoring problem, but it will never factor further. Okay, that second parenthesis will never factor further. So you can sit there and play with it and try to think, all right, well, what multiplies to 9 and adds to 3, but it's never going to work. That second parenthesis you don't have to worry about. Oh, let's do one more that's crazy here. 8a cubed plus 125b to the 6th. A cubed plus 125v to the 6th. Well, what would I cube to get to 8a cubed? Not 8a, because if I cubed 8, I'd get something really big. 2a. If I cube 2, I get to 8. If I cube a, I get a cubed. What would I cube? Maybe we should break this up. What would I cube to get to 125? 5. And then, maybe we need to think about this one. What would I need to cube to get to b to the 6th? What would go in that blank?
B.
Not just b. If I cube b, I get b cubed.
Wait.
What would I need to cube? What needs to go in this box so that if I cube it, I get b to the 6th?
B cubed.
B cubed would give me b9 because power to b squared. And what sign should I use in the middle of those? Plus, because we used the same sign. Same sign that we started with. Same, opposite, always positive. Set that up first.
A.
What goes in the first blank? How do I figure out what goes in the first blank?
Oh, we're looking at this.
Square the first thing. What happens when I square 2a? 4a squared. Make sure you square all of 2a, so 4a squared. Then again, I think it feels out of order, but I still think it's worthwhile jumping to the end, because what happens when I square the second term? 25b to the 4th. And then in the middle, I'll just multiply the two together. Don't have to worry about the sign. So 10 ab squared. And man, that second parenthesis looks really weird. Can I do anything with it? No, never. So you don't have to worry about that. Okay, the next worksheet looks terrible because it's long. But we're going to split it up. Today I'll say, it doesn't really matter, but I'll say today we'll do the evens. Tomorrow we'll do the odds. So let's look ahead at some evens. Maybe, I'm just looking at ones I've got previously circled. Let's look ahead at 14. That looks terrible. Looking at 14. Hayden, what do you see first on 14?
Take out 4.
I like where you're going. Take out a 4. Yes, I can take out a 4. Can I take out anything other than a 4? Yeah, I can take out an m. So we'll take out a 4m. Yes. Fernando, if I take away a 4m, if I divide them all by 4m, what does that leave me with? Well, I took out the m, and that leaves both ends. Zoom in some more. I divided by the m, so that the m is gone, but the n squared is still there. So the next one would be 7n, and the last one, -3. And that looks like something we could factor. Although I've got to figure out some combination of factors of 6 and factors of 3 to get to 7. And they have different signs. So, I've got to use 1 and 3. That's my only option here. So which set of 6 factors would I use to get to 7? 2 and 3. And who needs to be across from the 3? The 3, because that would get me to 9n minus 2n is 7n. Yes, no, maybe. Let's look at 22. Picking out some weird ones to look at. What would you say looks weird about 22? It's not in the right order. Well, you're allowed to rewrite things in a different order as long as you keep their signs with the right spot. So I'm going to rewrite this as b to the fourth minus 50b squared. What's the sign of 625 going to be? Plus. So still big numbers, but at least that looks better. 3 terms, so I'm pretty sure it's going to factor like that.
You can take out B.
That's got 4 to offer, that's got 2 to offer, that's got none to offer. So I can't take out a B. So it's a good thing to look for, but
There's like 1 B.
there's no B's to take.
It's B25. Oh, shoot. My bad.
So what could I multiply to get to b to the fourth? B squared and b squared would get me b to the fourth.
B squared. Minus 1 bucks.
And then, I don't know if you recognize your perfect squares that high. If you had one of those mean middle school teachers that made you memorize perfect squares up through 25. You did?
I wish I.
Who was that?
I forgot. She was at Newwood.
Miss Durkee?
Yeah, I do that too. Miss Turkey.
Miss Laughlin.
Yeah, Miss Laughlin.
Good on Miss Laughlin and Miss Durkee. Let's see. Signs would both be minus. Oh, wait. There's more to go. Because what can I do with b squared minus 25? Yeah, make it another one. That's what we did to start the day. So, Samantha, how do I factor b squared minus 25?
B minus 5, B plus 1.
Good. And I just need to do that twice. Which means you could have just squared each of those pieces. You could still square each of those pieces if you didn't want to write it all out. Let's flip to the back. There's more to go. Again, don't be overwhelmed because tomorrow all we will do is spend time working on this worksheet. So do some tonight, do some tomorrow during class, do some tomorrow night, and then you'll be all good. Let's look at number 30, because that looks weird. This might be the last one we do. Maybe not. We'll see. What? 30 looks weird, right? Because I wish something other than 2k minus 1 was there. Right? Like if that was 4x squared plus 5x minus 6, this would be a much easier problem. Yes? Like, I don't like the 2k minus 1. Well, we do this all the time in calculus, and that is, if you see a chunk of stuff that you don't like, you can replace it as long as you tell me what you're doing. So, I don't like 2k minus 1. I'd rather that be an x. So, off to the side, I'm going to say, hey, I'm just going to replace 2k minus 1 with x, because I know that's going to look a whole lot nicer. Maybe that feels super weird because that's probably the first time we've done that. But by the time you get to calculus, we do it all the time. Because it makes, that looks easier. I mean, still got a 4 and a 6, so it takes a little bit of thought. But at least I'm not dealing with the 2k minus 1 in there. Okay, so 1 and 4, 2 and 2, 1 and 6, 2 and 3. How to get 5 out of all that. Let's see. How to get 5 out of those combination of things. Oh, I think I see it. 4 times 6 is 24. That's not going to work. 6 times 2 is 12. That's not going to work, so he's out. 4 times 2 is 8. And 8 minus 3 is 5. So go 4x and x. But I need the 2 across from the 4. And I want the 8 to be positive and the 3 to be negative. Now, there's a small price to pay here. This problem started as a k problem. I switched it to an x problem. I now have to switch it back to a k problem. So I switched it to x to make the factoring easier, but now I've got to replace x. What am I going to replace x with? 2k minus 1. It's still well worth the time to replace the 2k minus 1 with x rather than have to deal with that. Okay, let's clean this up. So if I distribute the 4, that would be 8k minus 7, because negative 4, negative 3. And the second one's even easier, 2k plus 1. And you might see that 29 and 28 and 27 are all pretty similar. Let's see here. Any others we need to look at? It gets to some grouping stuff down here at the bottom. So yeah, to try some of the evens tonight, even if you don't get through all of them, try some of them. And then we'll do some tomorrow in class, and then tomorrow's assignment will be basically finish the worksheet. So kind of on you how you want to divide it up, but by the end of tomorrow, you should have it all done.